It's really good to be here. I really appreciate them all letting me come out here. Again, I live in Maine right now. It's a beautiful state. If you've never been to Maine, absolutely gorgeous. Right now, especially autumn, it's fantastic. You should come visit. It's amazing. I love Maine, love New England, but I also love Utah, and I'm really glad they let me come here and talk to you all today. So also, like he said, I work for Shopify. I work on specifically a framework called Hydrating at Shopify that's built on top of React. So if you use Shopify, if you if you've used their API, you have issues with it, if you have feedback and you're like, you wish something was better about Shopify, I'd love to talk to you. Also, I'm on the Winter CG, or the Web Interoperable Runtimes Community Group. What this is a new initiative that started this last year, where there's a lot of different JavaScript runtimes online right now. You have like Cloudflare Workers, you have Vercel, you have Dino, you've got Netlify, you've got a lot of different workers out there. And you know what? They're all slightly different. They all implement JavaScript APIs slightly different. So us at Shopify, we deploy to all of these things, and we try to build software that works on all of these things, and it makes it really difficult. So if you have actually experience on deploying to any of these things, and you've got opinions on what could be better about it, please come talk to me as well. I'd love to hear what your thoughts are on what you would like better about those runtimes, especially when it comes to consistency, whatever they may be. But we're not here to talk about that. We're here to talk about hydration and water. What does that mean when it comes to JavaScript? Well, I think to start off, to kind of really explain this, I think we need to talk a little bit about some basics. When I say this is basics, this actually can be really involved. If you've ever actually tried to implement some of these concepts inside your app, it can be very involved and actually pretty complicated and difficult to do well. So let's start from the very beginning. So when we have an app, you might initially, the simplest way to build an app in JavaScript is to client-side render it. And when I say client-side render it, what I mean is you're essentially sending down from the server largely no rendered content, pure just some basic HTML. And at the bottom of that HTML or somewhere on there, you're gonna have a script tag. Eventually that script tag is gonna run, some sort of JavaScript's gonna run, and after it runs, you're gonna render some content. So this is kind of my little image I have on the right here. It's trying to show the timeline of this is like your network. You've fetched the index. Eventually the index is completed. Now you've fetched some JavaScript. That JavaScript is run. If it's React or something, you might have some components in there. Those components are rendering. But guess what? Those components don't have data in them. So because they don't have data in them, you're going to render some sort of empty content until you make a separate network request, maybe one network request, maybe 50 network requests to go out and get data and render something to the page. So this is what's called a waterfall. It's called a waterfall because you have to do one thing, and then after that thing completes, you do another thing, and then you do another thing, and this is directly related to your app performance. So if you go inside Chrome DevTools, you load your app, you'll oftentimes see something that looks like this that's trending down to the right. As some things happen, then other things happen, then other things happen. And this is kind of bad, or it can be bad. And I need to take a disclaimer right here. Before I go further, there are some companies, some large companies, that might try to shame you for building an app this way. My goal is not to shame you and saying you are a horrible developer if this is what your app looks like. At the end of the day, there's very different purposes for different apps that people build. If your experience is, you're building some sort of business app, if it takes 5 seconds for it to load versus 3 seconds to load, that might not be the difference of life or death for your company or your project. For us at Shopify, it's a huge deal in that how fast apps load on Shopify's platform. Performance is a feature of our platform. So if we can shave another 100 milliseconds, 200, even 50 milliseconds off of our rendering, that applies to every merchant on the platform, which is over 2 million. So it's a big deal for us. So as I go into this, I'm gonna kind of dive into some performance, very nitty-gritty stuff. It may not apply to your app, but it may. It depends. I just don't want to say, hey, you're a horrible software engineer because your app maybe is not as fast as Shopify's app. It's a very different domain that you might be in. But at the same time, I hope you can learn something as we go through this. So we're talking client-side rendering. Let's compare that, though, to server-side rendering. So server-side rendering, it's somewhat opposite. Notice we only request this index.html file here, and that immediately has content in it. It immediately has some sort of content that's been rendered on the server, and we immediately show it to the user. So that's better in theory for performance for your application. Just immediately you show something to the user, there's no waterfall of requests to the server. But at the same time, you look down here at the bottom, we still have this script tag that eventually is going to run. That script tag's eventually going to run, and that's what makes our app become interactive. And that's really what hydration is. You're converting this static content that has been rendered by the server, whatever it may be, and you're making it dynamic and interactive. So until this script tag is executed, I can't click the add to cart button. If I click to the add cart button, it's not going to do anything. All it is a button. There's nothing there on it. So until some sort of JavaScript runs that adds an event listener to that button, nothing's going to happen. All right? So one question I have, though, well, what if there's a lot of data to load? When I say there's a lot of data to load, just because this rendering is happening on the server, you still need to fetch data for this to render. But instead of like fetching it in the client, you're fetching it on the server. So what if there's a ton of stuff that you got to fetch from some sort of API to render this page? In actuality, like naive server rendering is going to make your app slower on the time to first byte, because you have to fetch all that data before you can even start rendering index.html at all. And so here's a potential trade-off. So sure, you might show something meaningful to the user sooner, but you're not going to show anything to the user for a longer period of time. Interesting trade-off. Okay. Well, this is solvable with stream rendering. So when I say stream rendering, if we watch this process on the left, there's only one request to index.html, but notice as index.html is loading, content is loading on the page. We start with the header, and then like the product details load, and then eventually the recommendations load as well. So this is the process of the server. Rather than saying, hey, I'm going to wait to render anything until I have all of the data, I'm going to immediately open up a connection to the browser and start sprinkling down or sending down bits and pieces of HTML as I have it ready for the browser. So it's kind of a key difference here. So we're going to stream render stuff down. And depending upon the framework that you're using for your app, this is easier or a lot harder. Maybe really hard to do this well. So stream rendering sounds great and all, but what if the user interacts with the page before it has finished loading? So again, we come back here, we're showing content really soon. We might show this cart at the top of the page really soon, but again, that script tag at the very end still has to execute for it to be interactable. And so you might show that cart at the front really soon, but somebody clicks on the cart and nothing happens. So yeah, you're stream rendering and all, but the user experience potentially still is a little bit crappy. You're showing something quickly and early, but nobody can do anything with it. So not necessarily ideal. And this is directly related to your Lighthouse score for your application. So specifically, the time to interactive metric on the performance tab of your Lighthouse score, that's essentially the time for your app to hydrate, or that script to execute to take all that static content from the server to actually make it interactable. So if that takes a long time, and guess what? For a lot of devices, it might actually take a long time. So at Shopify, I can give you a few examples of potentially bad things that might happen. So we work with a lot of merchants that build on top of the Shopify platform. Some big merchants, like I'm talking $600, $700 million merchants who build on our API. And we've discovered all sorts of things that happen. So like, what happens if the user interacts before the page has finished loading? The maybe worst best case scenario is nothing happens. But the worst case scenario is an error happens. So this is a specific merchant I'm thinking of where an error occurred when you clicked the cart button before the app had finished loading. And once that error occurred, all hydration broke. So the app would never finish loading. So now this is a huge merchant on our network that, boom, anybody who's loading the site, they click something, an error happens in the background, now the app never finishes loading and you're pretty much screwed. They have to reload the whole page for anything to work. So that's like the worst case scenario. But what if we could have a better way of doing this whole hydration stuff? And that's where I want to show a few different ways that frameworks are handling this problem. And they're handling it in very, very different ways. So first off, I want to talk about Remix. Who here is familiar with Remix? It's built by some engineers, that at least one who's based out of here in Utah, Ryan Florence. Really smart guy, really nice guy. So Remix solves this in an interesting way. So if we consider this app, the same exact one we've been talking about, we have this add to cart button, we have this buy now button. Remix encourages you to wrap mutations or things that you're going to do, actions you're going to take inside their form component. And their form component underneath the hood is going to render a vanilla form element. And so if it's rendering a vanilla form element with an action and a method on it, if you've been around web development for a long time, or at least a few years, this might look really familiar. Before JavaScript was even a thing, this is how you manipulated data on the server, was just a simple form element with stuff inside of it with a button that submits the form. So what happens in Remix is if you're loading this index.html file and it has not finished loading and JavaScript has not hydrated, but you click the add to cart button, it will still work because it's just going to submit that form like it did 30 years ago, like 30-year ago web development. It's going to submit that form, but it's going to be a full page refresh. So it'll still work. It'll just be a full page refresh. And the cool side effect of that as well is this entire application can be built without JavaScript entirely. So you can disable JavaScript entirely in the browser and have an actual app that will work and be functional, add to cart, checkout, all that sort of stuff. It will just fall back to just using these vanilla form elements, which is pretty cool if you think about it. You're taking an app, taking advantage of all the new stuff that's available that you can do with JavaScript and all the power of it, but at the same time, if hydration doesn't happen or somebody, for some reason, they're crazy and they disable JavaScript in their browser, some some paranoid person that is scared of JavaScript, I don't know, for whatever reason they've disabled it, it would still work at least. And for us, in a platform, you're building a platform, maximizing accessibility and making anybody be able to check out and purchase something is a big deal. So that's Remix. So I'm on the Hydrogen framework at Shopify. So we build a web framework, kind of competes with Remix, Next.js. It's built on top of React, but specifically React 18 suspense streaming and server components and some other things. But we solve this a little bit differently. Sure, yes, we've got some primitives as well that allow you to do this form thing that Remix is doing. But there's a whole nother thing that we can do here. And the thought here, at least with React 18 suspense streaming, rather than having one massive hydration that happens once your HTML is loaded, what if you could have lots of small hydration events that could happen for different chunks on the page? So what does that actually look like? So again, with Hydrogen, we are stream rendering. So again, we're progressively rendering down the page. Well, as we're stream rendering, we will actually inject inline script tags onto the page. When I say inline script tags, that inline script tag is going to hydrate just a portion of the page. And this animation, what's going on, so again, there potentially could be no script tag that loads finally at the end, but rather you're loading this index.html file and you're stream rendering it, but you're also progressively injecting these script tags so that just the top header can hydrate maybe the middle content can hydrate, and then maybe the related content can hydrate. And the really cool thing is about React Suspense Streaming too, is they can suspend how it does the hydration based upon what the user is doing. So if the user clicks the add to cart button, they can say, hey, I know that this part of the page is higher priority than the header maybe. So maybe we can prioritize what we're going to hydrate above other things based upon what you're clicking and what you're interacting with, which is really cool. And this is React 18 Suspense Streaming. This is kind of the way React, more generally, the React core team is hoping to handle this problem. I'm kind of hand-waving a lot of this though, because it gets really complicated on how to do this well. I post a link at the bottom here. I'll post my slides later, but if you do just a search like React 18 Suspense Hydration, this is going to be one of the main things that comes up. This is written by Dan Abramoff on the React core team. It's like 20 pages long, and it goes into nitty-gritty detail on how this actually will work underneath the hood and all the strategies around it. It gets really complicated, and honestly, it gets easy to mess it up too. And it's not something that you would probably want to do on your own, but rather rely upon Hydrogen or Next.js or another framework to do for you. Unless you want to be that person who builds the Next.js or something like that, and can like really build a framework that can do this better than what they're doing. And honestly, as we go into this a little bit more, this is not a well-solved problem that I want to kind of explain a little bit further, and there's a lot of potentials for this to be improved. So that is React 18. But let's take a step back. Let's think about this. This is our app. We're talking about adding interactivity. How much is actually interactive on this page? I mean, pretty much everything on the product details part of it, other than the add to cart buy now, is static content. Do I really need to like download a ton of React components? Or maybe it's not React, maybe it's Vue, maybe it's, I don't know, Preact or something else. Do I need to download all of that content, execute all that JavaScript, just to render a description when the server already sent me the description when its server rendered it? Like, it seems a little bit redundant maybe. So let's look at this a little bit more in depth. So say that this is maybe what the code looks like underneath the hood. Maybe you have this product route. It takes some sort of product data, and then we render like a product title, like some sort of price component, a description, some action buttons, and this is the HTML that it might generate on the right. Okay, well there's a few interesting problems that might come up here. The first one, some of you might have encountered, if you're rendering that component on the server on the left with some sort of product, and now when it hydrates, it's gonna re-execute that component on the client. What happens if the product data is different in the client versus when it was on the server? Like, say somebody like published updates to your product, changed the price or something to it, so the client went out and fetched the product, and it happened to be slightly different than what the server had. So most frameworks will give you an error in the console and say, the client disagrees with what the server rendered. I don't know what to do. And so usually the framework will say, okay, the client's gonna take over rendering, and we're just gonna render what the client thinks is the source of truth. So what happens as a user experience in that case is you'll have a flicker. You'll have what the server says, I don't know, some sort of content, maybe the price is $10, and then eventually it hydrates, and now it changes from $10 to $20, I don't know, or however the content changed. And so you can easily get wonky user experiences when you server render and then when you hydrate if you don't have the exact same data that you're rendering between the two. And so usually what these frameworks will do, this is what Hydrogen does, this is what Next.js will do, this is what Remix will do, is we will actually embed into the page the data that was used to render on the server. So that when we subsequently hydrate on the client, we're using the exact same data so that we can guarantee that it's consistent so we don't have a flicker of rendering. Okay, that makes sense, yeah, but like, is there a little bit of redundancy here? If you look at this, Like, and now imagine that this is not as like simple as I've shown it in this example. Say you've got like a really big page with some complex data. You can get a huge amount of data embedded to the page as in like some format of JSON, and then you can get a huge amount of HTML content, which are like largely the same thing in some form or another. I'll give you an example of another merchant we had at Shopify who literally, and this is a $500 million merchant, literally had 20 megabytes of JSON getting embedded into the page. Clearly, that's a bad thing to do. Don't do that. Like, they were doing that because they wanted to render 10,000 products on a single page and server render it. Don't do that. But at the same time, maybe there's a potential or an opportunity to be more efficient. This is kind of what's called the double data problem with hydration and frameworks. And it'd be really cool if somehow you could, what if you could somehow augment the content that is produced by the server, because the server has to know everything about your application to render it. And then the client has to rediscover everything about your application to hydrate it. That's like incredibly redundant. What if the server could like augment the markup in the HTML with metadata to make it easier for the client or the front end to hydrate it? Because again, it needed to render all the components, it needed all the data, the server needed everything. So if the server could augment the markup to make it easier for the client to render and hydrate, we could have like a really sort of interesting like architecture of a framework. And what I'm describing here is something called Quick. Quick.js is a newer JavaScript framework. Sorry. And it's exactly what I explained right there. So if we look at the content on the right, we see there's all sorts of stuff in there. Well, like they're putting these weird Q object stuff on H1, H2. They're also putting these on-click like references to JavaScript bundles and such on it. And this is fascinating because if you look at this code in the script tag, check it out. So they're looping over every event that might occur in the browser. So events is a global. So we're talking like click, input, change, hover, all events that might exist. We're looping through those, and we're adding an event listener, a global one. This is like global event delegation. And when one of those happens, we look at the target, and we search in the DOM if there is an attribute that exists of this on event. So for example, these buttons have this on click event. If it exists, we're going to dynamically download and execute that JavaScript only when it's interacted with. And what this means is there is no JavaScript that is downloaded at all for this application to run until you start interacting with it. The only JavaScript maybe is this like little script tag that just initializes this event delegation at the global level. And so this becomes really cool. And I want to show you an example. So this is a basic to-do MVC application. Actually, let's come over here. All right, so just so you know I'm not lying to you, let's zoom in a little bit more here on the right. Notice there is no JavaScript downloaded. All we have is an HTML file and then 2 CSS files right here. Okay. When I click inside here, I type something, immediately we're downloading some code as I type it, and these are very, very small files. So this is like you're hydrating for each event. This isn't even at the component level, this is at the event level that you're hydrating. So if I'm like, okay, let's add a to-do hi there, and I hit enter, okay, that's a different event that just happened, and now we're hydrating more content for that type of event. Now if I come over here and I'm like, oh, I don't know, maybe I will clear out that one. Again, a new script is downloaded and hydrated just for that event. This is not like an islands architecture where you're like only hydrating like components and specific like portions of the page one at a time, more like React 18 or maybe Astro is going to do. This is at the event level that you're hydrating only as that event ever happens. that you're progressively doing this. And so this becomes really, really cool. And so you look at these files, it's not like these are crazy big files. Like again, this is essentially just the event handler for this particular action that you're taking. And for a to-do app, you're clearing something out. It's going to be pretty simple how you're actually implementing that. And it's just that logic that is downloaded for that particular action. And this is really, really cool. And this is all possible, again, largely because if we look at this, again, everything needed for hydration is a part of the markup. So if you look at the markup inside here, there's all sorts of interesting stuff that you don't necessarily need to care about as an app developer when you're using Quick. It's a part of the framework. But this is cool stuff though. And so we're running out of time. I want to kind of summarize a few basic points here. One, hydration might or might not be important for your app performance. It really depends upon your domain and what you're trying to solve. Whether or not you come inside here, you use Quick versus React versus Solid.js versus Astro versus who knows what. Really, there's a lot of reasons you'd pick one over the other. If performance is a key part or if it's a key feature of your product, like you really need to consider this stuff. One thing, so if it is important for you, you should really assess how your user experience is affected when JavaScript is slow to load. And you can simulate this inside Chrome DevTools. You can slow down the connection to be like 3G speed and just see how does the app behave. Again, the worst case scenario is that your app just errors before JavaScript loads and then it never recovers. That, like I said, that is an actual thing that we've seen happen, at least on our platform, with people building on Shopify. Don't do that. The last thing that I want to emphasize is there's a lot happening in this space. There's a lot happening in JavaScript frameworks. There's a lot happening with React. There's a lot happening with Remix, with Astro, with all these frameworks. And I want to emphasize, so we work regularly with like the React core team and other like engineers that work on these projects. These people are not geniuses. They're not better than you. They're not like amazingly like they're just software engineers like anybody else. They just happen to be paid to work on this all day, every day. And my point in saying that is if you have ideas on like hydration, on the future of web frameworks and how this stuff can be like better, like all it took is like some people to come up with this crazy idea on this on-click stuff to come up with a very unique and interesting way about building a JavaScript framework. And again, these aren't like genius sort of developers. These are people just thinking outside the box. And I would encourage you, if you have interest in this, go out there, play with these frameworks, think outside the box, and build something new and build something better than what we have today. But thank you.